right, good afternoon. Hey, I have two jobs at Intel. One is managing the data center business, the storage, the networking, and the server infrastructure. The other is actually worrying about the next wave of connected devices. Intel's predicting 15 billion connected devices on the internet by 2015. And if you think that's conservative, Ericsson's out talking about 50 billion connected devices. So I get to worry about putting broadband into the car, point-of-sale terminals, ATM machines, vending machines, all those kinds of fun things. But today I wanted to give you at least Intel's perspective on what does it mean for all this big data that we're talking about here today and what's happening back in the data center to do the analytics behind that big data. So first and foremost, just take a look at the numbers. It's absolutely phenomenal. 48 hours of YouTube video uploaded every single minute. 200 million tweets per day. I was trying to figure out what that was per second. And 7.5 billion photos uploaded every month. Today we're talking about 4 billion connected devices. And again, we're on a path that's going to just explode relative to 15 billion by 2015 and 50 billion predicted by 2020. And probably the most amazing statistic I've heard in the last 10 years is that there was more data transmitted over the internet in 2010 than the entire history of the internet up until 2010. 245 exabytes or quintillion bytes of data in 1 year. So our vision is very simple. If it consumes electricity, it's going to ultimately end up computing. And if it computes, it's going to end up connecting to the internet and generating data. And so putting that together, 300 exabytes of data this year and about $455 billion of enterprise spend. Now, we were in a position before, very similar like we were today. You know, Intel introduced the Pentium Pro back in 1995 and had a great run delivering the standard high-volume server up until the year 2000 and the dot-com bust. And if you remember, everyone thought they had all the SPARC Netra servers they needed in 2000, and they thought for several years the market would tail off and perhaps never get any bigger in the server space. And since then, we've delivered about 2.7 times the growth, up to about 16 million chips a year from a market that was literally a couple 100,000. So why is that interesting from a Web 2.0 perspective? Well, you heard earlier about the investments required to get some of these businesses started. When Intel entered the server market, the average server price was $58,000. And today we're under $3,800 and dropping. So once again, we're sitting here in 2010 and people are saying, hey, this is a slow growth market. And the simple prediction from Intel is that instead of doubling this business over the last 10 years, we're going to double it in the next 5 years. And there's some amazing statistics behind this data. We're assuming that in 2015, when you order a server as a line of business manager, 3/4 of the time you order a server, you're going to get a virtual server, not a physical server. You're going to get a VM. You're not going to know you're getting a VM, but you're going to get a VM, not a physical server. So enormous growth. The other part is every single part of the business is growing. From mission-critical infrastructure converting from RISC to Intel-based systems for the international banking transactions, to the private cloud infrastructure, to the small businesses, to 3D movies and the workstation market. Cloud and HPC obviously being our largest markets, growing well over 20% compound annual growth rate. And now networking and storage. So that same standard high volume market that took a $58,000 RISC server, drove it to $3,800 and made Facebook one of our largest customers as an end user, not just an OEM, is now happening to storage and to networking. So whether it's EMC or NetApp or HP or IBM or Dell or others, that storage infrastructure is converted from a couple years ago where Intel was less than 20% of that storage compute. Now, with EMC becoming kind of a analytics appliance, not just dumb drives and sheet metal, Xeon's becoming a fundamental element to that, and we'll end this year at about 80% share of storage. And specifically for the Web 2.0 companies, as they flatten out the network, we're also seeing some of those proprietary ASICs that have driven very high-priced switching and routing convert over to Xeon-based infrastructure as well. So our business, particularly in the Web 2.0 companies and the top 10 routing and switching companies, is up about 60% just in the last 18 months as well. So this whole concept of standard high volume, standards-based servers, now moving into storage, now moving into switching and to routing, and all that's going to help drive down the cost of services. Our simple vision at Intel, we're going to add 1 billion people to the internet by 2015, going from 1.5 billion to 2.5 billion people. So you take that combined with those 15 billion devices, and our vision is basically to connect everyone to everything. And that's before you talk about machine to machine. So I thought I'd give you just a couple examples of what are we going to do with big data. You know, if you have all this data available to us, you're in data overload. What are some of the kind of interesting things that we're seeing out there? Well, the U.S. Geographical Society about a year ago started the Twitter Earthquake Detection Project. How many people have been part of TED? Nobody. All right, we're in San Francisco, right? There was an earthquake in Virginia, August 23rd of 2011, and it took several minutes for the U.S. Geographical Society to actually understand it's an earthquake. But within 1 minute, there were 40,000 tweets that had gone out on the earthquake, and it actually reached New York City, which felt the rumbling of there, far ahead of the actual official U.S. Geological Survey saying that New York was going to get hit. Now, that's interesting in and of itself, but if you look at 5,500 tweets a second, if you're in an area that has less seismic detectors and stuff, it could save real lives in the future as you get out into some of the emerging markets. If you look at what happened in Japan, the average network traffic is that little yellow line. And while most of the infrastructure was down, most of the mobile network, including the WiMAX network in Japan, was actually up. Intel, our Scuba sales office, was hit immensely. Sprinkler systems were going off, water was flowing up on the floors, ceilings were caving in, and literally within minutes on their WiMAX-enabled notebooks, you can see the amount of data traffic. We were getting live pictures and even videos of what was going on in Japan. So the key message here is, you know, you can never predict, and the new reality of the world is that you're going to have these huge spikes whenever there's an incident, whenever there's a political uprising that was just talked about, whenever there's a natural disaster. We have to have infrastructure that's reliable, available, and scalable so that it just doesn't go down, and we can do a pretty good job of saving lives in the future. Now, the other example is we've basically delivered a 550x improvement in performance at 500 times lower cost since we've been in this kind of supercomputing class business. And at the end of the day, big data analytics is like supercomputing. In 1985, when Intel first got into the server business, you could predict a hurricane 2 days in advance at about a 300-mile radius. So what that basically means, if a hurricane's heading towards New York or Boston, you're evacuating millions and millions of people because you just don't know the prediction. I just had this experience about a month ago in Tokyo. One of the typhoons was heading that way, and they literally didn't know 2 days in advance whether they were going to shut down the Narita airport, move the planes out, because you had one of those cones going out with just 2 days' notice, right? Now look, today, you're analyzing terabytes of data, and we can only get basically a 48-hour warning still, but we're now down to a 100-mile radius. So we've improved the accuracy of this prediction, so you're only evacuating about a third of the population that you would have before. But the goal, if you look out to NASA, is actually to deliver 1 million times the performance that we can today. To get basically the same forecasted accuracy in your weather 2 weeks in advance as you can get in tomorrow or the next day's forecast. And then we can get down to evacuating basically just a zip code, a 10-mile radius. So what we've done to supercomputing and the economics of supercomputing, delivering 500 times the compute at 500 times less power, or cost rather, is fundamental to what we're going to do in big data analytics. And so at supercomputing, I made a declaration, hopefully in conjunction with the US government, that will deliver a supercomputer 125 times more powerful than today at only 2 times the power by 2018. And so we fundamentally believe Moore's law is alive and well. The performance is going to continue as it has, and we're predicting big things. So if you look at how to go solve some of these most difficult problems in the world, you'll see that not just in weather prediction, but in cancer detection, we had cancer detection that used to cost millions of dollars, take 2.5 hours to get the results, you can now basically do real-time CT scans on the operating table at 10 petaflops. So the world's largest supercomputer today, if it was available in a CT scanner, could do a real-time CT scan while the doctor was operating on the table. And we're a few years away from getting that down to seconds of a real-time operating. Genome sequence used to cost about $1 million to get a genome sequenced. We're a couple years away from it being less than $1,000. So you can get medications basically tailored directly to you, tailored to your specific genome sequence. So the key message is, from Intel, adding 1 billion people to the internet from 1.5 to 2.5 billion people, connecting 15 billion connected embedded devices by 2015, up from about 4 billion. We see a massive amount of data growing. We said 300 exabytes already this year, growing to well over 1,000 exabytes of data crossing the internet by 2015. And Moore's Law, alive and well, driving not only into the server space, but specifically for Web 2.0, into the storage, the networking, switching, and routing space as well. Thank you very much.
Just 1 second. Kirk, it was very good of you to step in for your ill boss. I appreciate that, and I hope he's better by the time earnings is tomorrow, I think. So he's got to get better. I know that's why he's not here. Sitting there with an ice pack on his head going, I got to deal with Wall Street. So I want to, 2 things. Number one, you said Moore's Law is dead, but the New York Times said it was, I mean, Moore's Law is not dead, but sorry, but the New York Times in the summer had a, it was picked up everywhere, this story about how power and heat were in fact killing Moore's Law. So that's just not true?
No, I think many of you may not have caught it, but this year we announced one of the biggest revolutions in transistors since the invention of the transistor. We went from basically a 2-dimensional transistor to a 3-dimensional transistor. So the challenge with Moore's Law has always been, how do you shrink and shrink and shrink this? And think about it as, if you got down to a city block and it got smaller and smaller and smaller, how do you continue to advance? And what we basically did is reinvented the transistor and made it 3-dimensional. So now you can build skyscrapers on those small city blocks as well. So what that means is we're already at 32 nanometer today, 22 nanometer next year. We're already working on 14 nanometer and a technology generation beyond that. So I can confidently say we've been in the server space through the most aggressive run in Moore's Law in 25 years. I mean, we've gone from single core to dual to quad to 6 to 8 to 10 cores. And that's had tremendous economics in the marketplace, and we think that's going to continue.
I'm glad to hear it's not dead. The second thing is, you mentioned the Internet of Things and 15 billion connected devices, which is an impressive number, but what are they? Like, what are these devices?
Yeah, so
I mean, not just iPhones and whatever, but like what else?
Well, I mean, we have a massive amount of software developers out there, and so what's exciting is they can start developing on the PC and then move it on to these intelligent connected devices.
But do they have to be intelligent?
Well, I think 15 billion of these devices will be connected to the internet, and more intelligence will go in them. So the things that are exciting to me are a car. So how many people think broadband isn't going to get into the car? Right? I mean, we're going to have the average car is going from 5 to 50 million lines of code. A high-end automobile next year will have about 300 microcontrollers in it and 12 cameras. And so you can envision a world where the car 1.5 miles from you is communicating with the cloud. Just the sensors figured out it slipped on a corner on ice. It'll communicate it back to the cars behind you, so you know, hey, be careful, the car going 55 miles an hour went around a corner and slipped a half mile in front of you. That's a cool one.
You just get chips in the deer that jump in front of you. That would be good.
Put them right there in the back. Yeah. The other one I'm excited about is just vending machines. So there's like 800 million.
Of course you're excited about vending machines.
Hey, what's not to be excited about vending machines? Even Mark was talking about them. But if you think about it, a vending machine was like a non-connected device. It basically had a stupid microcontroller in there to keep the Coke cold. And then we got to the point where you can tap your card to pay, so you got instantaneous payments. Now you're getting connected to the internet, so you can actually predict, hey, I'm a vending machine. I'm at a public pool, and it's going to be 90 degrees for the next 6 days, and I sell twice as many Cokes on a hot day than a cold day. And you can start auto-routing your trucks now to replenish those vending machines.
Those would be trucks that Google made, so no one has to drive them. Or you could just get 3D printing and make the Coke in the vending machine.
That's right. So you're routing trucks, and now you put like a smart sign on the front of it, and now the Coke machine knows what person's in front of it and can start, putting in a special order for what kind of Cokes you're.
I think you're giving us some awesome examples of what we meant by the data frame. So
yeah.
thank you for stepping in and doing it.
No
I really
problem.
appreciate it. Thank you very much.